Welcome. Today we're going to talk a little bit about reliability, and the key here is we're going to go over some of the basics of reliability as it relates to classroom assessment and assessments in schools. So to start this discussion, I want you to construct an essay question on reliability and validity. So take a moment, stop the video, write out a short question that asks someone to explain or demonstrate their knowledge of reliability and validity, thinking about this course. And then, after you do that, I'd like you to reflect on some questions. First, is your question measurable? Second, what are your criteria for performance? Third, what will your scoring rubric look like? Fourth, what level of Bloom's is your question? Is it a knowledge level question or is it a higher order thinking level question? And then finally, how will you grade this? How will you know that the student has achieved what you want them to do? And how will you know that you can grade each of the assignments in a similar fashion? And it's this last attribute, the idea of being consistent, that is the central component of reliability. There are several traditional views of reliability. One is this idea of temporal stability. That is, simply put, that the same form of a test on several occasions will give us very similar results with the same examinees. So the classical sense of this is test-retest. For classroom applications, this isn't a practical approach. Repeated measurements are likely to change as the examinees, the students, mature and develop. They learn other things in other parts of their lives that may have nothing to do with your instruction, but they're going to change anyway. And so this idea of temporal stability really isn't appropriate for classrooms. Temporal stability is something that we would expect to see, say, on a psychological measure where we're hypothesizing that it is a trait that is stable over time. But not in education, and certainly not for classroom assessment. Another type that is more common actually in classroom assessment, or in assessment in schools anyway, is this idea of form equivalence. And that's simply put two forms of a test. So for example, we might have Form A and Form B, which is often the case for tests that are given in districts as part of a large-scale testing program. So for example, one local school uses the ITBS, the Iowa Test of Basic Skills. And on the ITBS, there are actually several forms that are possible. So as the teacher in a classroom hands the test out, each child might get a different form, in sitting in a small group table. So there might be 4 different forms, A, B, C, and D. And these are all established to be equivalent. That is that the same student, if they took all 4 forms, would perform relatively the same. It's not precisely the same, but approximately the same. And this is called alternate form reliability. This is also not a type of reliability that is typically used in classrooms. We don't generally give 2 different versions of a test, that we might scramble the order of the questions to discourage cheating or other kinds of undesirable behavior on the part of students. The third type is called internal consistency. And simply put, this is the coefficient of test scores obtained from a single test or survey. In other words, imagine that you were to give a test with 50 questions. And if we compared all of the odd numbered questions with all the even numbered questions, that would be split half. So split half is the simplest type, where literally we would split the test in half, and we would take the scores of a child on one half of the test, and we compare it with their scores on the other half of the test. And we would expect them to do roughly the same. If they didn't, then it would mean that the items within our test were not particularly similar. Internal consistency can also be computed with what's called Cronbach's alpha. And what Cronbach's alpha does is it attempts to estimate the average of the reliability of all the potential split halves of the test. And this is the measure by which we most often compute reliability for assessments, and is the internal consistency measure that we would use, say, for example, if we were looking at the reliability of a test and using SPSS to generate that reliability statistic. One can compute internal consistency. In Blackboard, there is a section under optional readings. It's called measured measures. And in Appendix C, you'll see that there is information on how to compute the internal consistency. I'm not going to go into it here because it's not central to our course or the curriculum for the course. But if you're particularly interested in this, to see how this works by establishing the variance of the set and the average distance of each item from that average, and then computing internal consistency, you're welcome to take a look at Measured Measures Appendix C. The math folks out there will be, no doubt, would enjoy looking at that. And we'll be looking more at other measures of central tendency in the next few weeks in the course as well. So we've talked about what types of reliability there are, and that, in essence, internal consistency is the only viable way that we would measure this in education. But what is the point of reliability? Well, reliability is a necessary but insufficient condition for validity. So, for example, if I have a needle on the scale and it's 5 pounds from 0, I'll always over-report my weight. Is the measurement consistent? Absolutely. But it's consistently wrong. Similarly, take a look at this example of 4 sample targets from a shooting session. On the top left, we see an unreliable and invalid session. It's unreliable because the shots are scattered all over the target. It's invalid because they failed to center in on the center of our target and really strike at what we were trying to hit. On the top right, notice that we are invalid and unreliable. Although we have one shot in the center of the target and the average of our shots is in the center of the target, it would be difficult to say that we are consistently measuring what we intended to measure. The bottom left corner here, where we notice that we have very tightly clustered shots, but they're invalid. They're not measuring the center of the target. They're not measuring the thing that we had set out to do. Only in the bottom right corner do we see we are both valid and consistent, reliable. We have both characteristics in play. We've hit the center of the target, what we were aiming for, and we've done it in a consistent fashion. Now, obviously, tests in schools are not target practice, but this is a good analog. For example, if we are measuring in a mathematics test children's ability to compute numbers, but on that test, we are actually measuring the children's reading because we are introducing a number of word problems, we might very consistently measure those children's abilities. But what we're measuring isn't mathematics computation, which would be here. What we're really measuring consistently is the reading performance. Over here, we would see a better alignment between mathematics computation and what we had intended to measure. So we've done that consistently. We're measuring kids' mathematics computation skills, and we're doing it, we're actually aligned to what we intended to measure. Up here, we might be introducing all sorts of construct-irrelevant variance, all kinds of noise, the time of day, how kids were feeling. And it could be that the average of those is that we're measuring what we intended to measure. But it's difficult to say that we're doing it in any consistent fashion. It's certainly not working well for this child, even though it might be working well for this child. And up here, this might be an example of both an unreliable measure and one that is measuring maybe irrelevant factors, such as reading achievement versus mathematics computation. Why should you concern yourself with reliability after all? Well, in a survey of teacher-made tests, many teacher-designed instruments had internal consistency scores of 50% or below. So in other words, for these individual assessments, half of the performance of students was error variance, just random effects. This is really concerning when we're making high-stakes decisions based on this kind of information. So as teachers, it's just as we would expect in large-scale assessments that the assessment questions and the types were both reliable and valid, the same type of standard we should hold up for our own assessments, and to check that they're functioning the way we think they are and they're measuring what we think they're measuring. So what kinds of things impact reliability? Well, test length. Overall, the longer the test, the more reliable it is. The first factor that increases reliability is the length of the test. So all other things being equal, the more questions you include, the more reliable your assessment is. This makes sense if you just sort of step back and you think about this logically. If you ask a person 3 questions about their knowledge of a particular topic, you could get lucky. You could ask 3 questions that they know, and they'll come out and they'll look as though they're quite knowledgeable. On the other hand, if you happen to ask 3 questions about topics that they're not particularly familiar with, they will wind up looking less knowledgeable than they really are. If, on the other hand, we increase that to 10 questions on a particular topic, the chances that they won't know all 10 questions are much lower. And the chances that they, by random chance alone, will know all 10 questions is also much lower. Now say, for example, we ask 50 questions. If we ask 50 questions on a particular topic, and they're all aligned to that topic, it would be very difficult for someone who's not very knowledgeable to answer all 50 correctly. And it would be very difficult to ask 50 questions on a topic where the person who was in fact knowledgeable wasn't able to answer any of them correctly. So test length has a profound influence on the overall reliability of your test. Variation in scores is also an important component to internal consistency, to reliability. That is, that if everyone scores perfectly on your test, then there's no variation whatsoever, and the reliability, at least in terms of internal consistency, is 0. Likewise, if we have all the people on the test earning extremely low scores or no questions correct, the reliability will approach 0 as well. So what we would expect is this sort of bell curve, this normal distribution of scores, where some folks do very well, most folks score in the middle, and a few folks score quite poorly. Similar to the test length question, the number of subjects taking the test also has a large influence on the internal consistency. If we have 3 students, for example, who take a test, imagine that they get 3 different scores. Well, if they happen to be 3 very bright students, then we're going to have an unreliable estimate that would make us believe that all students would do very well. If we have 3 students that did very poorly, we would make the same kind of error, but in the opposite direction. But the more students that we have that we're collecting scores from, the more likely we are to make an accurate estimation of what students on average know about the topic. And then finally, if we vary the difficulty in the items, that is, we vary how hard each item is, this will directly influence the variation in scores, which I've already mentioned. So these are the factors that impact reliability. We can also take a dynamic look at internal consistency, and this is an active link in the PDF that's attached to this video lecture on the Blackboard site. If you click on this, it will download this reliability calculator. And I've got a separate piece that shows a more dynamic look at this. If you look at the old video on reliability, take you through several examples of how to use this calculator to manipulate the variables of the number of questions and the number of students and see how that influences the reliability. So what is the upshot? Well, when you use a selected response or performance assessment, the number of items that you have is critical. If you have too few items, you cannot have a reliable assessment. And then secondly, inter-rater reliability, that is the degree to which 2 raters agree on the same score for a student, is completely dependent upon the quality of the rubrics that you're using, how well the raters have been trained, and the clarity and the quality of the questions themselves. So the lower these factors are, or the less reliable these factors are, the less reliable the overall ranking of the rater is going to be. And as a result, the lower the overall reliability estimate for your test. There are some concerns about using internal consistency for estimating reliability in school tests. One is that it is based on the need for variation. That is, as I mentioned before, without any variability in scores, if all the students get a perfect score, your test is considered to be unreliable. It assumes that you have a normal distribution, but we know that that isn't always the case for groups of students in school, and that there are serious issues with estimating reliability if these two factors aren't in place. And so the question that I'm going to leave you with this particular topic is, can you have a high performance and be valid and reliable at the same time? In other words, if all of your students really meet the standards in your classroom, let's say that every student has demonstrated that they are excellent at solving 2x3 multiplication problems, and we test all of them and they all score perfectly. Does that mean that your test is unreliable? In an internal consistency framework, that's exactly what it means. But is that in reality what that means? So one of the things that you'll be asked to reflect on in this course is this issue of, in a criterion reference world, are reliability and validity the same questions? Do we always expect to get the same results? And can we separate out internal consistency from reliability overall? So I want to leave you with a few items to reflect on and to try to identify some potential threats to validity and reliability for each of these scenarios. First, Mr. Dorr administers a 50-point performance assessment, creating assessments, before he's covered all the information in his course. Second, Ms. Maverde allows her students to grade their own essays. 3. Mr. Kurtz decides to read the reading subtest of the MEA to his student with autism. 4. Ms. Hollinger decides to administer her chapter science test to Group A while Group B finishes their final project. During the next period, she reverses this. Number 5. Ms. Baker decides to give her final assessment in social studies in French because it is an integrated social studies / foreign language course. How would each of these decisions impact the reliability of the assessment? And, in a related note, how would each one affect the validity of that assessment? I want you to just consider these on your own, but these will be things that may come back around either in a project, an assignment, or on the exam.